talk about normalization. So part of the data design aspect is to decide which classes we want to use, which should be attributes, and if certain classes might be a little bit too big, and we should split them up into multiple classes, so that part of that of our design process, right, is referred to as normalization. Right? It's kind of the question on whether should we just put a whole bunch of fields into one single entity, or would we be better off at splitting it up into multiple entities, right? Into multiple classes, into multiple tables, and so the basic reason or the basic principle that should drive those decisions is that we want to avoid redundancy, right? Because we want to avoid inconsistency, right? So imagine that you just had one big worksheet, right? Imagine Excel, right? And if somebody imagine that you had a form that lots of folks are answering or filling out, and you have one form that perhaps some folks are coming out from the mall, and you have folks that you want them to fill out. You're asking them questions, and you're filling out the questionnaire, and imagine that, and presumably each time you fill out the form, you have one single record that captures all the questions that you ask them, right? And if you want to look at them in a worksheet, typically you'll have all the questions and all the answers in one long row, right? In one single worksheet. And imagine that now perhaps a family comes out and you ask them the same question, all of them, and 3, 4, 5 folks in the same family, you're going to have a lot of the same answers to the same questions, right? Especially about where do you live, what addresses, and whatnot, right? And so when you look at for each person, you're going to have an individual record. So perhaps you're going to have 5 records where the address is going to be repeated multiple times, right? So the question might be: is that the most effective way to represent that data, right? And as we'll note today, that redundancy of having the same information repeated multiple times breeds inconsistency, right? As time goes on, that information tends to become inconsistent. It might have been consistent at some point, but eventually it might become out of sync, right? Either because somebody misspelled something, or things that were supposed to be the same, they're no longer the same. Take my last name. My last name. Well, there's a debate in my family whether it's Annunciata or Annunciato. And during the Second World War, a lot of people were displaced, and in some dialects in the south of Italy, they pronounce the O like A, and the person who was writing it, just wrote an A. Well, that's what my family says. That it's originally O and it became A, and some folks have says A and it became O. Anyway, we're the same family, but we have inconsistency, right? Some folks spell with A, some folks spell with O. This is a very common problem in data in data collection and in synchronizing things that are supposed to be the same, but they're not, right? Because over time they tend to just imagine two clocks where you have 2 clocks and 2 wrists, and at some point they're the same, but eventually over time one becomes faster than the other, and then you don't trust either one. Which one do you trust? You have these family feuds, right? And then nobody really knows what's the truth. So we don't want to run into those issues. It's better not to have redundancy in the first place. So ideally what we would do is that we would take those addresses, right? Instead, break them out into maybe a different worksheet, right? Where we capture the address only once. And anyway, that address really, in reality, only exists once, right? So we should not. There shouldn't be that data represented multiple times, because it's not true. It's only once. And then somehow we have to relate, saying that these 5 records of these 5 people somehow are related to this one record where you have the address. Okay? So again, no redundancy, no inconsistency. So normal forms are considerations on what types of redundancies could there be, and what types of inconsistency could they take us into, right? And how do we fix it? All types of redundancy we can fix it by splitting the table into multiple tables, and then somehow relating them together, right? So there's different levels of inconsistency or different levels of redundancy. Some of them are blatant, right, and they'll jump at you immediately. Some of them are subtle, right, that perhaps are not evident right away. You need to think about it a little bit whether it is indeed a redundancy or not. So the idea is to decouple the data so that whenever you're going to be doing an update, right, that update should only be to one table. Right? There's no need to go to multiple tables to do the update. So first the first type of redundancy, right, that is referred to as the first normal form, right? Meaning we would like to be able to have our tables, our data, represented in such a way that they meet first normal form. Okay, so this fixes one type of redundancy. So let's take a look at the this type of redundancy. First of all, we don't want any repeating fields. No repeating fields or columns, right? So certainly we don't want to waste time and capture the same information over and over. So let's take a look at this example. So here we have a customer table where we have one record, one customer per record. This feels pretty innocuous, right? That we're holding these three folks in three different records. But somebody might come around and say, wait a minute, but I have more than one phone. How would I represent that, right? So one of the naive ways that we might consider representing the phone is that, okay, well, I'll just create a comma separated data, right? So instead of just having one telephone in there, I'll have it multiple phones on the same field. The problem with this is that now the field really doesn't, the data that you're storing here really doesn't capture what was meant for, right? That you have one single phone. Also, the searching, you're searching for a particular phone now becomes so much more complicated, right? Because there's no longer one single phone, but there's multiple phones in here, right? You need to consider that comma in there, right? So also indexing no longer is trivial here because you're considering multiple phones as opposed to just one. So the other alternative would be I could split it up into multiple columns, right? Where you have you have multiple phones, you have one column per each phone. The problem with this is that this doesn't scale very well, right? What do you have an arbitrary number of phones? There's no way to represent this without adding yet another column or modifying the original schema that we had from before. So that's also not very productive. The other alternative is that then I'll represent it in different records, right? To represent the values are different, right? Like the phones here might have different records. Notice that we're not merging it into an existing field, or we're not generating a new. We're not growing horizontally in columns. Instead, we're growing vertically in records. And this might seem also a sensible solution. The problem is that we're introducing redundancy across multiple records, where we're capturing the same information of non-key fields multiple times. Again, we have a problem of redundancy. So none of these three strategies is a good solution. Typically, the solution for fixing any of these types of problems is almost inevitably breaking the original schema into multiple tables, so that instead of having it represented multiple records in the same table, we split them up into two tables, and then we have the relationships here, right, where we have Jane Wright having multiple telephones. the phones are only represented only once in a separate table, and then we just have links. We have references of that Jane Wright. It's not drawn very well. What happened here? I think the font change here. What's going on? Exit full screen. Oh. Huh? Okay, so the presentation, when you put it in present mode, it screws it up. All right, so that's what it's supposed to look like. All right, so that's so that's what we mean, right? And it can be summed up. The strategy can be summed up by the data must depend on the key, right? So if you know the key, if you know the particular key where somewhere lives, we'll say that the data, whatever fields you have here, they only should be dependent on that key, right? If the key is different, then there should be a different value, right? If the key changes, then the value should change. Right? You shouldn't have this multiple, repeated over and over if it's a different key. Right? If the key changes, then the values here have to change as well. Okay? And the same thing here, right? If the key is a different key, then if you know the particular key, you inevitably know a particular row. That you wouldn't have two rows, right? That have different keys that would have exactly the same values in there. Otherwise, you wouldn't be able to distinguish between them. All right, so now let's look at a little more subtle type of redundancy. And in this case, it's a redundancy that occurs when you have keys that are compound keys, right? Where the keys are not just one single field, but multiple fields. Where we're saying that a particular record is a unique record if the combination of the keys is unique, right? Where we're enforcing the fact that that the combination of these two fields has to be unique. For instance, you might have the same exact course, but they're being taught at different semesters, right? That we wouldn't allow, multiple section, the same section multiple times with the same number for the same course. Right, that the combination between a course ID and semester here is unique. Right, so we enforce it by saying that these are both primary keys as a combination. That makes sense? Okay. Once you go further, then you say that here's the data, the normal data that is non-key. Right. These are fields that are not necessarily unique. They can repeat. There is no constraint on them. And we'll notice that, let's see, we're capturing a couple of things here, that for this particular course, we have the seats and we have the course names. If we do an analysis on this, we realize that the course names, right, notice that they're dependent on the course ID. Right, so there's these two over here, CS 1500, they're programming, and these two over here, 5200, are databases and whatnot. Right, so you have this field over here, course name, dependent only on half of the field, of the key. See that? It's not dependent on the semester. Right? The semester could be whatever. Right? It really is that these two are related to one another. Right? The course names are only related to the course ID. Right? If that's true, then I can introduce some redundancy here. Right? It only depends on half of the key. So the way to fix this, right, is to instead of having multiple instances of the programming course name, instead of having that multiple times, we split it up. Right? We have a separate table that has the representation of courses only once. Right? We have the course ID and the course name. Right? So like this, it's split up into a separate table where you have the course name and you have a foreign key of those course IDs back to the enrollments and the seats and whatnot. Okay, so we refer to this type of normalization. We call it second normal form, right? Where the data is dependent on the whole key. So the first normal form says that it depends on the key, right? The second normal flow set is depends not only just one key, but the entire key, right? If there's more than one key, it has to depend on the entire key. Okay. So here's another example where we have employee, we have skills, and indeed we have we have a table that has a compound key, right, which is employee and skill. So the combination of employee and the combination of skill has to be unique. It would make no sense for Alice to have the same skill repeated multiple times, right? That's why we make the combination unique. Alice can know HTML only once, or Alice can only have the skill of CSS only once. But notice here that we're capturing, not only that we're capturing the skill and the employee combination, but we're also saying where are they currently working, right? They're working in Cambridge, Newton, and whatnot. Notice that here we see that there's some data that's being repeated over and over, but in close inspection we see, well, is that redundant or not? We start to look for what we refer to as functional dependencies. Are there dependencies between these values, between the fields, not dependencies between records, but dependencies between fields, right? And we realize that the location of the person can only depend on the person themselves. The person can't be in two places at once, right? If you know the person, you should be able to know where they are currently. Okay, you can't. It makes no sense to say that you have two records of Charlie, but they're in two different locations. It would make no sense, right? So there's a functional dependency between the employee and the current location. So the dependency goes between current location, and only part of the field doesn't go. Is not dependent on both of the entire field. Yes, on the entire key. Right. So it only depends on the employee. It doesn't depend on the skill. So again, it's breaking second normal form. Right. So next week, I'm going to give you an example like this. You'll be able to answer: is it breaking first, second, or third normal form? Okay. And how would it fix it? So the way you would fix it is that you would then break it up into into an additional table, and you would capture the location only once, right? And then have foreign keys that refer to the employee themselves. So again, now if your table is in second normal form, it is also implied that it is also in first normal form, right? So there are additional constraints, right, of what you expect your tables to represent. So say this table over here is already in second normal form because we have the professor and they all depend on the entire in the entire key. So Alice, Bob, Charlie, they all depend on both the course and the year, right? But you have additional field over here that goes along with the professor, like for instance the date of birth, right? So that date of birth can only depend on the professor. It makes no sense that the same professor would have a different birthday, right? So in this redundancy, you would be okay with first normal form, you would be okay with second normal form, but you would be breaking what was referred to as third normal form, since this would allow us to inadvertently, right, make changes to the birth date, right, and have inconsistency and have two records that are supposed to be the same value. It would allow us to enter bad data. So what we have found here is dependency between fields, right? Where one field depends on another field. Here, these fields depend on the combination of the course and the year of who's the professor, right? If you know the course and you know the year, you might know who the teacher is. But this birth date depends on another field, right? So what third normal form says, not only do you depend on the key and the whole key, but only the key, Right? You only depend on the key. You don't depend on fields that are not the key. Right? Like this one has a dependency between each other. Like, or for instance, if you had you're trying to represent the car, and the car might be that you want to capture the make and the model, right? Where the make might be a Toyota, and the model is a Corolla, right? And so those two fields might be dependent on each other, right? Where if you know the make, you don't necessarily know what the model is, yes? But vice versa, you do, right? If you know the model, you definitely know the make, right? If it's a Corolla, it has to be a Toyota, right? So there is a dependency between the two, so between two fields that you need to find these dependencies, right? Because when there is a dependency between fields, it's a hint that there might be redundancy, right? And you run into the risk of inconsistency. So course and the year are the primary key, and other fields depend on them. Right? The other fields depend on the primary key, so it's in second normal form. But we can mistakenly change the professor's birth date, right? So we need to fix the third normal form. So the third normal says that you should depend on the key, the whole key, and nothing but the key. So basically, we split them up into professor and the year, only represented only once, and then foreign keys back to the courses who teach those courses. Okay? Make sense?